Hello, fellow Ag Nerd. Thank you so much for joining me for another episode of the Future of Agriculture podcast. My name is Tim Hammerich, and every week I get to sit down with the farmers, founders, innovators, and investors shaping the future of the ag industry. Happy Thanksgiving to those of you listening this week and are in the U.S. Many of us are sitting down here to a Thanksgiving dinner, and it's a really good time to talk about today's topic. Over the past few years, the term nutrient density has been popping up more and more, and there are a lot of claims being made about farming practices, a lot of which coming from the regenerative agriculture movement, producing more nutritious or more nutrient-dense food. But is this true? I mean, if you increase, let's say, the amount of one nutrient in a product, are you really making it more nutrient dense, or are you maybe just doing so at the expense of another nutrient? And if there are more of any given nutrient in a product, does that necessarily make it healthier? Well, the truth is, we don't really know for sure. There's no agreed upon standard for nutrient density in any given product, and many people and companies are not letting that ambiguity stop them from latching onto the term and running with it for their own marketing purposes. I mean, you've heard evidence of that right here on this show on previous episodes. Also, without collecting a large amount of data on the various compounds in agricultural products, we can't really even say that it matters. Our guest today is making progress in defining nutrient density with data and has created an open source, consumer-priced handheld bionutrient meter that can provide a real-time percentile of nutrient compound levels in 8 different crops so far. He has a vision of someday using nutrient density as an important data point to optimize our food system in a variety of ways. But first, we're going to need the data to define what the nutrient profile should look like in each crop and the instrumentation to test this in every level of the food system, which he's going to be the first to admit that we still have a long ways to go toward that end. We have on the show Dan Kittredge. Dan is the founder and executive director of the Bionutrient Food Association. He was an organic farmer for more than 30 years and founded the BFA with the mission of increasing quality in the food supply. Dan's perspective is healthier food comes from healthier plants, which comes from healthier environments, meaning the soil and the microbiome. So if we can develop reliable and accessible measurements of healthy food, then maybe we can use that as a critical metric for a better food system. What's exciting about this work to me is that questions such as what does quality mean for various agricultural products has historically been kind of ambiguous. I mean, the way we've basically answered that is it safe? Is it consistent? Is it abundant? Is it aesthetically pleasing? Then it must be high quality. But in the future of agriculture, we're going to have the chance to define that in a deeper and clearer way with actual data. Now, there is this debate out there about whether or not our foods have lost their nutrition over time, meaning foods decades ago were healthier than they are today. And that's really not the point here. We're not really going to get into that. The point is that there's evidence from Dan and the Bionutrient Food Association that levels of certain nutrients and compounds in today's food can vary wildly. Dan says that their testing over the past several years show massive variation in these nutrient levels. Dan's vision is really interesting. Once we have a clear definition and the instrumentation to give everyone access to the data, it could create a feedback loop that can optimize our food system for true quality. He believes this can nullify the need for a lot of the labels that we see out there right now about how food is grown, because what will actually matter is the data on the quality of the food and its environmental impact. You're going to hear him share the effects this could have on farming practices, on genetics, on health, and on consumer choice. Some of what Dan shares with us may stretch your thinking here a little bit, and you may find yourself wanting to see the evidence. And that's okay, because really the story here is what Dan and the BFA are doing to search for the data to inform this really interesting thesis. In order to make sure that this was a pre-competitive effort so that nobody could sort of hijack the term food quality, Dan and the team have made their device open source. He says it's a very early version of what they will need in the future, but it has allowed them to initially start collecting data, at first with consumers at grocery stores and farmers markets, and now growing into working with 150 farmers as they did last year. Dan starts our conversation off with an overview of the Bionutrient Food Association.
The BFA is about a 10-year-old educational nonprofit. Our mission is increasing quality in the food supply. We define quality by, flavor, aroma, nutritive value, health-giving attribute. We've helped to coin and popularize the term nutrient density. When I started looking into these things 15 years ago and putting A and B and C and D together, I was like, so all these modalities are talking about different techniques and processes, but who's talking about results? Permaculture doesn't have a results metric. Organic does not have a results metric. Biodynamic does not have a results metric. They're talking about practices and techniques. And so it seemed to me to make sense, and this is a part of what I picked up at the Acres community, the concept with the refractometer and bricks, that there was nutrient variation in food. It seemed to me to make sense that the quality of the food should be the thing that we're focusing on, being our objective. So it's not about the volume per se, but about the nutritional value. And it sure seems to be that those quote unquote, the buzzword now is regenerative, but the biological practices, the organic, whatever the practices are you want to call them, the things that cause life to work more well correlate with better water cycle function, better carbon cycle function, better soil carbon levels, better biology in the soil levels, better pest and disease resistance, lower cost of production, better nutrient levels, better flavor and aroma, better health outcomes for the animals that eat that food, whether they're chickens or pigs or cows or humans. It seemed to me that the nutritional value of the food, it was the center, the high ground, the point around which, as far as I'm concerned, no one can disagree or no one will disagree. People generally will say, yes, food should be nutritious. And so that's really where we have found our niche. When I looked around, I said, who out there is focusing on this point? Who is focusing on the nutritional value of the food as an objective? And I couldn't find any organization out there globally that was doing it. And so I said, well, I've been looking for a purpose. This seems like a reasonable one, something to do with my life. And so that's really where I started.
I like the way you frame that up with outcomes. From multiple angles, it seems like we're moving in this direction of looking at systems based on these outcomes, which, if I were to try to distill it down, it would be kind of, nutrient value over carbon footprint, sort of like outcome. And a big part of that nutrient value is kind of what I want to dive deeper into next, is like you mentioned things like flavor and aroma and nutrient density. Flavor and aroma, I think, are pretty intuitive to everybody, but let's talk more about nutrient density. How do we define that and how do we measure it?
Well, the first thing I like to say is we don't have a definition. And so let's be really clear about the fact that we don't know the answer right now, at least from my perspective. Just step back one level, I was witness to my parents and their circle taking a word that in chemistry meant contains carbon and converting it into a word that meant doesn't have chemicals applied. Organic used to mean contains carbon, and now it means nobody used chemicals, at least in the general lexicon. So in the food science, canon, nutrient density is a measure of average nutrients per calorie. So if you talk to a food scientist, they'll tell you that kale is more nutrient dense than rice because it has more average nutrients per calorie than rice does. And so we are in the process of, I would say, developing a new definition for the term. And our focus is on this kale versus that kale, or this rice versus that rice, and defining the nutritional continuum within those crops and saying, this rice here is in the 80th percentile of what rice could be, and this rice over here is in the 20th percentile of what rice could be, and being able to apply that sort of a numerical assessment to it. Foundational in it is that we're not saying it is nutrient dense or not. It's not a binary standard like organic or, non-GMO or, I guess people are starting to try to put together regenerative standards, et cetera. Those are binary. You are or are not. What we're saying is life is a continuum. Everything is somewhere in the continuum. So let's try to define that continuum and then apply those numbers to it so that let the market work from there. And so, as an organization, we have been working for 4 or 5 years now on this project. We've got, 3 different labs, 2 here in the US and 1 in Europe, that have been running samples on more than 20 different crops. Because we're a nonprofit and everything we're doing is uncharitable, donations. We haven't had the resources to fully characterize the biochemical spectrum of nutrients in crops. We've only been able to look at, 12 or so elements and a couple compounds. So things like copper, zinc, calcium, potassium, sulfur, and then also antioxidants, polyphenols, and in grains, protein. By running hundreds of samples of each of these crops, in many cases also along with those samples, the management data, the environmental conditions, planting date, tillage type, fertility program, a variety, irrigation, details, along with the soil, hundreds of carrots, hundreds of samples of wheat, hundreds of samples of spinach, etc. We found some quite dramatic variations, 3x, 5x, 50x between the spinach with the lowest level of antioxidants and the spinach with the highest level of antioxidants. The wheat with the highest level of zinc and the wheat with the lowest level of zinc, etc. So we have defined variation across a number of metrics and found that, basically every single crop we've looked at, every single metric we've looked at, variation is dramatic. It's not 5% or 10% or 50%. It's much larger than that. And that is different from what we are proposing nutrient density to be. We're proposing nutrient density it's a final number, but it comes from a more complete biochemical assessment. So there are proteins, there are lipids, there are, carbohydrates, there's polyphenols and terpenoids and alkaloids, there's enzymes, there's vitamins. Any crop contains a fairly significant number of different compounds in the order of thousands in most cases. And so our thought is, until we have characterized the variation of at least all those families of compounds, we shouldn't presume to say this is the overall nutrient density score on this carrot versus that carrot. So it's a long-winded way of saying I consider this to be original research that has not been completed, that we are endeavoring to take leadership in, and we feel very passionately about this being open data, not proprietarily controlled. But I would say we don't have a definition of nutrient density yet for things. Beef is going to be different than carrots, it's going to be different than rice. And so we have to go through systematically all these crops, characterize the variations, and then with people who have the credentials to make statements, begin to define that and say, this is roughly what an 80th percentile carrot looks like and the 20th percentile carrot looks like.
Right. And is one of the reasons for needing some sort of index, because you could have high levels of XYZ nutrients. So let's say wildly high levels of zinc, but it might come at the expense of another valuable nutrient.
Exactly. More is not always better. Levels and ratios. It sure does seem that the compounds that correlate with flavor and aroma, which are generally the more complex secondary metabolite compounds, are built when everything else is in place. Our hypothesis is that a carrot that doesn't have much of a flavor is less nutritious than one that really has an amazing carrot flavor. That we actually may be coming at this through a heavy hitter, hard science, just get the big machinery out and run thousands of samples strategy. But on the other side of it is our evolutionary pathway. And we actually have inbuilt, very sophisticated nutrient monitoring devices called our nose and our tongue. Apparently, our DNA has prioritized the function of the nose and the tongue as far as like the amount of code over every other function, right? 30% of our DNA is dedicated to smelling and tasting, which is a remarkably large amount considering all the things that our body does.
When we hear from a startup that says, we're going to change the food system because we are growing more nutrient dense foods, it would seem to me that they're often just talking about one nutrient, that's saying, like, we're growing something with higher protein or we're growing something with more, whatever the case may be. So it sounds like maybe that at this point should be met with a little bit of skepticism until we really define what nutrient density is in terms of some sort of index. Am I thinking about this correctly?
Yeah. I mean, we can watch the regenerative conversation and see, there's a bunch of people who thought it was a good idea to engage farming in a way that is beneficial for the environment. And without having a data set that can confirm that, got a lot of people out there making claims about regenerative. And I think this is the problem with marketing and isms and bandwagons and fads. nutrient density was not even a term when we started. We helped create the term, and now it's gotten to the point where it's associated with a good thing, and so people want to claim it. But our whole point is, if we don't have an empirical framework for directly perceiving it that everyone can have access to, you shouldn't trust the claim. We've seen, in our data collection, people who have said, I engaged in these practices, whatever, minimal till, no till, cover cropping, and we can see increases in organic matter, increases in nutrient levels. And we've got people that claim regenerative, and we don't see those increases in organic matter and nutrient levels. So the label, the term, and the data need to be interrelated. So I would say, please, yes, engage in a serious conversation. What is nutrient density? Our whole point is, if we don't have an empirical structure around which to have this conversation, we shouldn't be throwing the word around. And let's work together to build that data structure. This is a pre-competitive space. If it is true that increased nutrient levels correlate with better health outcomes and better environmental outcomes, let's identify this as a space around which we want to have good, honest data, and then incentivize every company in the world to profit by leading in the space.
Okay, I love that. Let's talk about where you are in that journey right now and what's it take to realize your vision, which is a real, reliable nutrient density. I keep calling it an index. Maybe that's the wrong word, but nutrient density measurement tool.
Yeah. Well, there's the instrumentation and then there's the index, which are two different things. Yeah. I mean, without the index, it doesn't matter what instrumentation you've got, but that is also part of the puzzle is, in our mind, having it be possible for anyone in the supply chain, be it a grower, an agronomist, a buyer, a wholesaler, a packer, a processor, a retailer, a consumer, able to assess in real time relative nutrient density so that labeling and marketing are irrelevant. If nutrient density is a continuum from 1 to 100, I guess there are models that we can envision where a grocery store has a machine that they can flash a light at the carrot and spit out a label that says, on this date, this was the relative nutrient level. But I really want to try to get to a point where that empirical transparency and ability to perceive is at everyone's fingertips. And I think that's the only way to keep such a standard honest going forward. As I said before, my parents, helped set up the organic certification system. And at this point, there's a lot of things that have an organic label, which would be sacrilege to the original definition of the term. So how do we maintain that integrity over time? My suggestion is only through empiricism and instrumentation. The end game concept being that in your smartphone, one of the cameras is a spectrometer, and you can take a picture of the beef or the milk or the rice or the carrot and get a real-time reading, not a QR code, a real-time reading, actually assessing nutrient levels in real time.
And I think the technology is there. I know you all have kind of a handheld, what I think is a spectrometer to look at some of these nutrients, but how close are we to more of the index side of things? I imagine that's going to take more research and more funding dollars, but what's the bottleneck to getting there?
Dollars. Yeah, just tens of millions. We have the capacity to do a lot fairly rapidly. The issue is there is no ROI directly for that money. There is no IP. The data is open from the foundational design. And so it's basically aligning the charitable interest with that kind of resource. I would say that's the most significant impediment right now. Everything else we pretty much have. It's just the number of dollars to run the samples on the machines to get the data set. And, most people that are putting in tens of millions of dollars into something want something back for those tens of millions of dollars.
Yeah, and this does get back to, several conversations we've had here on the podcast, not just with nutrient density, but also with funding models of, just very few food and ag related solutions that are great for a venture capital model. And there's a lot of need that doesn't fit it. And where does that money come from? So I imagine this conversation, what we're talking about right now, is where you're spending most of your focus with the Bionutrient Food Association?
Yes. And the next generation instrumentation as well, because the meter we've got right now is a handheld consumer priced flash of light meter that, is calibrated for 10 crops, gives you readings, but it's still pretty wonky. I use the metaphor of an Apple II, which people who know that it was like basically their first personal computer. And if you weren't a coder, it didn't provide much value. And even then, if you were a coder, you couldn't do a hell of a lot with it. But now we've got iPhones, which are profound in their capacity. So, we've got an Apple II. We want to get to the functional, metaphorical level of an iPhone, but we're not there yet. So, yeah, I mean, there's a few steps left to accomplish. We're not like going to have this done next year.
Sure. Well, it's a worthy endeavor. I think if we were sitting down together at the days that the Apple II came out, envisioning what was possible with an iPhone would be very difficult to do, but I'm going to ask you to try anyway. When your Apple II becomes an iPhone, figuratively speaking, what's going to be possible for farmers and for the future of agriculture?
Well, I think broadly, we're going to be able to engage much more intelligently and sensitively and proactively with nature. So one thing is that we get the feedback loops that are real time. And so with the metadata that we have about management and causal factors, we can be able to flash a light at the corn plant while it's growing and say, oh, looks like we need 2 grams of cobalt applied per acre as a foliar spray. The B12 levels aren't quite there. And that will address A, B, and C potential issues down the road. So that ability to in real time modulate fertility and management practices for growers will obviate the need for most agrochemicals, I would suggest, will maximize the functional build of soil carbon and ecosystem function. So I think, the opportunity to realize the regenerative vision of agriculture being a systemic solution to the climate dynamics becomes much more plausible in that scenario where we can have that feedback loop. As well, I think the implications on human health are quite positive. We understand that most chronic disease has at its root nutritional deficiencies or imbalances. And so, a lot of what is on the shelf right now is pretty low in the continuum, right? I mean, what we found from the data we've collected so far is that most crops are somewhere in the 15 to 30 percentile, say, whether it's copper or zinc or polyphenols or antioxidants. If we look at the full spectrum, most crops are in we'll call it the 25th percentile. The vast majority of what's on the shelf has in it a quarter of what it could have. And so the implications for human health across the board, if our food is more nutritious, are that the level of chronic illness and degenerative disease and overall malaise, I think, can be dramatically reduced. Beyond that, we can start talking about all kinds of other societal implications, but the hypothesis that there's a direct connection between soil health and plant health and human health, and being able to use economic leverage to raise the bar across the board, I think does put us in a place for a viable future for civilization as we recognize it. I mean, I'm not sure if I've talked about the full economic dynamic, but the basic principle is if a consumer can choose between 3 bags of carrots or 2 jugs of milk or, 3 varieties of ground beef based on nutritional value, our hypothesis is that they will choose the one that's of highest caliber for themselves and their families because they're inherently selfish. They want the best for their children. And so if we bring that economic driver to the food supply, we begin to incentivize those practices which facilitate those results. So that's the general concept, is that we use empiricism, transparency, and economic self-interest to drive this thing. And to accomplish that, we need the meter, the index, and the metadata.
Sure. Well, I think we could do a full another episode on the feedback loop between, a potential nutrient density index and farming practices, and how interesting that could be for pest management and for quality and for all sorts of things. But anything else that we didn't touch on that you think for a high level episode about your work that we should make sure we mention?
Well, I mean, different organisms have different functional digestive capacities. And, when I'm teaching a course, I'll use the example of a bale of hay. And I'll say, if any of you walked in here this morning, you might have considered sitting on a bale of hay, but you probably would not have considered eating it. Whereas if a cow had walked in, she probably would have considered eating it and not sitting on it. And I frame it as a question, and people say, does this make sense? They'll say, yeah, that makes sense. And I say, well, why is it that it's food for a cow and not food for us? And they say, well, because cows have 4 stomachs and we don't. And I said, yeah, that's exactly right. Different organisms have different levels of digestive system function. So we can understand our bacterial pathogens, our fungal pathogens, our insect pathogens as organisms that have a certain level of digestive system function. And when a plant is growing well, when a plant's microbiome is functioning well, it builds in its body compounds that make it indigestible to bacteria and fungi and insects. So, one of the things that I experienced on my farm in fairly short order as I began to apply these principles from a more integrated, coherent sort of conceptual framework was literally the pests and diseases that I had sort of considered normal for decades disappeared. And it was because the plants became indigestible to them. So, think about the implications about if we didn't need them in the first place because the plants were healthy in the first place. Those compounds that make the plant indigestible to those pathogens are exactly the same compounds that we call flavor and aroma. I mean, the implications of all this, when it begins to sort of you wrap your head around it, are very exciting. If you're looking for deeper systemic improvement. If you're just focusing on your ROI from your VC investment, then, perhaps it's not so inspiring.
Yeah. And can you talk more about that paradigm? Because I think that's really interesting, especially to kind of think of it as sort of a fork in the road where it's not just not using chemicals, it's actually developing systems that can work biologically. And maybe could you give us just a high level overview of that paradigm?
Thank you for focusing on it. I think this is a really, really important point. It is a paradigm shift. It's been a few 100 million years now during which plants of all sorts have been able to feed themselves and take care of themselves without farmers applying things. And so the first thing to understand is that in nature, plants have evolved the capacity to take care of themselves. And there's no reason why we can't create that dynamic in our quote unquote fields. When we understand how plants evolve to function and we can support that, then our need for inputs diminishes. Our viability as a farmer, economically and otherwise increases. Quality of life increases. So, yeah, I mean, I think a lot of the organic community that I was brought up in, it was sort of organic substitution method where you're still tilling, you're still doing monocultures, you're still adding fertilizer, you're still killing insects. You're just, doing it all under an organically approved model. And that still, I would say, is coming from that reductionist paradigm as opposed to the biological paradigm. So in the politically correct terms of the day, we can talk about colonized versus indigenous or something. It's a perspective. Is the land there for us to profit from, or are we in symbiotic relationship with it? And so the general insight that I like to start with is that plants evolved a symbiotic relationship with their gut flora, very similar to the ones that we have as animals with our gut flora, as in plants cannot digest their food by themselves. They've evolved, the symbiotic relationship with bacteria and fungi to digest and make food for them, to feed them. And so it's only when that microbiome is functioning well that we should expect the plant to function well. And so I don't really particularly care whether you're growing almonds or corn or cucumbers. It doesn't really matter too much as far as a fertility program is concerned, which crop it is. The foundational dynamics are applicable across the board. And, if you understand that the microbes in the soil are the bottom of the food chain and the plant is in the middle of the food chain and the animal, we'll say, is at the top of the food chain, our focus should be on creating an environment for the bottom of the food chain to flourish. So that means sufficient air in the soil. It means sufficient moisture in the soil. It means, sufficient food for the microbes, which generally is an organic construct, whether it's plant root exudates or cover crop, plant residue. So air, water, food, and then some basic minerals for biochemistry. In many cases, we have limiting factors of, boron or sulfur or molybdenum or cobalt. In many cases, a couple pounds per acre of these critical elements is all that's needed for the biological system to kick into gear. But without, a pound of molybdenum per acre, plants can't sequester fixed nitrogen. In nature, corn can fix nitrogen in symbiosis with the appropriate microbes, but only when they have the enzyme, the nitrogenase enzyme, to do it. And at the core of the nitrogenase enzyme is one atom of molybdenum. So If you don't have 1 pound of molybdenum on your acre, you're probably going to have to add nitrogen fertilizer. But if you do have that and other things are functioning, then you don't have to add fertilizer, for instance. So food, air, water, minerals, and then finally the microbes themselves, in many cases, based on how things have historically been done. Some of those communities of microbes are not present. And so inoculation, I think, is a really important piece of the puzzle as well, whether it's a seed treat or foliar sprays or other ways of addressing it. Worm castings are great and can be done on thousands of acres quite inexpensively. Ensuring those core dynamics are present at all points in time is really, in my experience, what is needed to be able to stand back and have nature do most of the work. And that sort of is part of what led me to do the work with the BFA, was to say, I grew up on an organic farm. My parents ran an organic farming organization. I didn't know a lot of these things. They weren't part of what I was taught. And, I was able to implement them and achieve the kind of lifestyle and results that I think a lot of people are looking for. But I haven't heard a lot of other educational organizations out there talking about this. So that's part of why I'm not a full-time farmer anymore. It's because the message has been spreading so successfully.
I appreciate that. Thank you very much, Dan. And if anyone's listening and wants to engage with your work, especially if they're like, with the Gates Foundation or somebody that wants to put a bunch of money behind this cause, what's the best sort of call to action we can give the audience?
I would say, check out our website. The bionutrientinstitute.org is where we are hosting most of our research work. The general organizational website is bionutrient.org. Certainly, those are places to, see more of what we're doing, to contact us, to join as a member, to make a donation. So, yeah, we're certainly very receptive to people who want to be engaged and support. It's really only through that collaboration that we can have a plausible scenario of success.
Okay, well, thank you very much to Dan Kittredge for being on today's show. This interview stretched my mind quite a bit to consider what the implications might be of getting all this right. The index, the instrumentation, the feedback mechanisms for having quality-driven food and farming systems. This data-driven approach, especially when coupled with the data on things like environmental impact, could eliminate the need for a lot of the messaging and infighting that so often confuses people about food and agriculture. They've been working with labs in Michigan, France, and at Chico State University in California, and they're building a new lab, is my understanding, in Massachusetts. So if you're interested at all in this concept and becoming maybe a farmer partner, a citizen scientist, a donor, or organizational collaborator of some sort, go ahead and visit their website, bionutrient.org. Anyway, thought-provoking conversations for your Thanksgiving week. I hope you found that worthwhile. Thanks so much for your time and your attention. I never take it for granted. I'll be back next week with another story of ag innovation.